Right. You probably know I'm Vincent Mainey. I'm a general practitioner. You probably already detected by the first few sentences I was born in Liverpool and spent some of my time being educated at the still a black school of elocution. Very flattened to be here, and I mean that. This talks about a concept which I think is actually central to dowsing, simply because just listening to everybody else talk, both in the lectures and all the coffee and all the rest of it, you all seem to have accepted, as I do, that the ether actually still exists. It ceased to exist at the turn of the century. Suddenly scientists, having previously accepted as self-evident, decided it wasn't there anymore, based on a very simple experiment which didn't turn out quite the way the experimenters thought it was going to. And what would happen to people like yourselves would be, at the age of 15, when you first confronted with this change that took place at the turn of the century, you'd ask some very logical questions, but you wouldn't be given logical answers. And we'll look at those questions again and re-examine them, because that was the time when probably all of you here who have a scientific bent would have asked these crucial questions, and you would have been fobbed off with the answers. So I'm going to take a look at that. Now, this topic, why am I doing it here? Why am I doing it now? The time has come. The ether theory is being brought out again, and eminent scientists are taking a fresh look at it. I say it was dropped at the turn of the century, but there was a lot of good people around at the turn of the century who felt it ought not to have been dropped. I should start by putting my flag up and saying what I do. I'm a dowser, and I use dowsing quite almost every day. I'm a member of the Psionic Medical Society, and we use dowsings to help the patients who have these rather esoteric diseases where medical science is pushed to its limits and they're still ill. They end up with people like myself and Gordon Flint, who do our best to help them. But we tend to do it, or I certainly do it, as a map dowser. I'm not picking up any energies from them. But for those who are into energy forms of dowsing, sensitive to earth energies, water, etc., this, I think, will have a certain relevance to you. For those who are interested, therefore, in geopathic stress and environmental pollution, and also those who are in the healing energies, the vibrational energies, the basis for what you're doing, I hope will be provided by this talk. Now, the topic is high-powered, but the presenter is not. I'm a GP. I'm not a high-powered scientist, so I'll do my best to answer questions which are valid, but forgive me if I can't give you the replies as though I was a top scientist. But I have been given this topic 25 years of thought. And 25 years ago I published a paper which you're welcome to have a copy of now. It might just help you to follow the talk. Is it okay to just dish them out, or would you prefer them at the end? This was published in 1970. It's not a very good article. I was a medical student at the time. I say it's not a good article because it wasn't well written. I've recently rewritten it and republished it and added bits and pieces that have happened since that article first appeared. I was quite an old fella. I was 27, I think, 28. I'm 54 now, and that was published in 1970 in the Newcastle Medical Gazette. I've still got the original copies of that. So those of you who are orthodox scientists are, in a way, stuck in one camp, that is the non-etheric camp, and those who are perhaps unorthodox and here are probably in the etheric camp. I'm going to introduce you first to Mainey's principle, which goes something like this. When you get a load of nutcases gathered together in one place, they all think they're normal. Now, everybody that comes here talks in a way that is totally different to how you dare talk when you go away from here, because if you start talking in the same sort of language to people who don't understand, you will be a nutcase. But when we're all, in a way, abnormal, but we're supernormal rather than subnormal. And I think that's because we talk in a way that the ether is self-evident, and don't be alarmed at that, because there are a lot of people who, in the history of science, were on your side. The title E equals mc squared then is a re-examination of a major event which took place at the turn of the century, and I'm going to ask, why was it dropped? And if we now look at this as though the thing hadn't been dropped, the problems that science now has may well be soluble, whereas it's getting increasingly difficult. If I start by asking you to go back to the situation at the turn of the century, which is also the same situation that you faced when you were 15, and somebody, I have to, someone would have asked you to believe this, that the sun over here and the earth over here was moving around in a vacuum. And you were asked to believe that this vacuum was nothing. And yet, the earth, as it were, knew, because I can't think of a better word to say, the earth knew that the sun was there because it acknowledged its existence by going round it in a perfectly ordered manner, which it had done for millions and millions of years. And yet, we were told there were obviously huge forces here, but there was nothing to transmit them. There was no medium at all. That was the vacuum that we were expected to believe. Now, before the turn of the century, scientists, including Michelson-Morley, believed the ether. In fact, Michelson-Morley attempted to find the ether. That was what they were doing. They weren't trying to prove it or disprove it. They were just trying to find it and measure it. And it was a bit of an embarrassment to them, and they didn't give up. I mean, the first attempts were a failure, and they tried again, and they kept on looking, and they kept on looking, because they hoped to be the people that says, yep, we found the ether. Unfortunately, they didn't find it. I'll mention a little bit about the interferometer, the methods they used to try and detect the ether. But on the basis of that experiment, which failed insofar as it didn't prove the existence of the ether, but it did not disprove the existence of the ether. It was a neutral result. But funny things were going on at the time of the century, and people were forced very rapidly to go into one camp or the other. You either had to go into the ether camp or the non-ether camp. Now, let me just tell you what Newton said about this. To suppose, you've heard of Isaac Newton, have you? Anyone? To suppose, let me just get a drink, my mouth's a bit. Is this one mine? To suppose that one body may act on another at a distance through a vacuum without the mediation of anything else is to me so great an absurdity that I believe that no man who has in philosophical matters a complete capacity for thinking can ever fall into. In other words, if you believe that the ether doesn't exist, you're bloody idiots, according to Isaac Newton. And he'd given this idea a lot of thought. And it's this, I challenged yesterday when I was doing a workshop where I was given a hard time, but thoroughly enjoyed, to those people who were skeptical about the existence of the ether to tell me, and I've asked many, many, many high-powered people. I even corresponded with Stephen Hawking for a while and John Taylor, and I said, look, before, I've got some mathematical equation speech to look at later on, which I was trying to get them interested in. But when they dismissed the ether, I said, yeah, okay, but tell me, how does the Earth go round the sun? What's keeping it in place? Is there anyone that can give me an answer to that question which would allow the non-existence of the ether?
I'd sure like to know what Hawking and Taylor told you.
Hawking told me nothing. Taylor came up with all the latest theories, you know, about quarks and charm and vortexes, etc. But really, it didn't tell me what the vortex was in. It was just so that's the central question. I think it was that, and of course electromagnetic forces as well. You probably know that magnetism and electromagnetic forces exist in vacuums as well. We can again put that simply, that if you have an experiment, it comes with me, say you've got a tube here and you evacuate it of all air, so that in effect becomes a vacuum, and you've got a north pole at one end and a south pole at the other. They will react to each other. This knows that that's there, even inside, you know, this vacuum, where we're told there's nothing there at all. No ether, no nothing. And yet this responds to that. So it's gravitational and electromagnetic forces, which we know are there. They're easy to prove, they're easy to show. What's difficult to prove or difficult to show is what's happening. And now scientists have come up with alternative explanations, but you can't conceptualize them. We've got a few high-powered scientists in here today. Can anyone conceptualize what's going on here and what's going on here? Because it was these things that Michelson and Morley accepted. They were looking for this mysterious substance, which was called the ether, the thing that transmitted these forces. But they hadn't found it. And they were trying hard.
Science tells you ask too many questions.
Pardon?
What science tells you is you ask too many questions.
I don't. Well, who was around at the time when all this happened? Well, there was Max Planck, there was Maxwell, there was Lorentz, Einstein, Bohr, Rutherford, Heisenberg.
I'm just going to use my prerogative as a presenter here, your introducer, to tell you that you had a comment from the audience by an eminent professor of physics at Munich University, and he said, what science is telling you is that you ask too many questions, and I think it would be entertaining at this point for you to address that question or that comment and have a little interchange with Professor Betts.
Well, it wasn't the questions that I was asking, it was questions that scientists were asking. You know, what is the nature of the ether? We could determine, they remember the turn of the century, almost to a person accepted the ether. Now, it was abandoned very simply. Now, have I got it right? Are you trying to tell me I shouldn't really ask these questions? Well,
what was called ether before, one sort of a mechanical ether, you know, with mechanical properties, and that kind of ether certainly doesn't exist. But that if you have 2 points in space, A and B, and there is something, the correlation or an interaction, then even modern physics assumes that something is happening, and they replaced the concept of the ether by the vacuum. Now, what is vacuum? Vacuum is not nothing. It's a rich empire with anything. Vacuum can create particles, destroys particles. A lot of things are going on in what physics calls vacuum. So it's a perversion of the original idea of a vacuum.
Which really, they're using the word vacuum to replace ether.
In fact, it's even more strange. Any matter, what we think of what matter is an exception. Normal is a vacuum, and matter is a fluctuation of the vacuum. And that's also how one thinks one could explain in parentheses how the world came into existence. It's a fluctuation of the vacuum. But that, of course, doesn't answer the real question we have.
Well, I think it's fair to say then that the question is a valid one because scientists themselves are asking it. And that from what you've just said, I would say that they've reinvented the ether. They've just called it something else. And so let's sort of have a look at what they ditched and how it's creeping back. I've said earlier on it is creeping back. It was totally ditched and it's creeping back in various forms. And at the turn of the century, there are quite a few people in favour of it. Lorentz and Max Planck, Maxwell, and a few of the others actually supported the ether theory, but it was abandoned because the didn't require it, and the Michelson-Morley experiments failed to detect it. And so the scientists really had two camps to go, and you either went with the flow or you went against it. And the majority of scientists, rather than sort of miss out and be left in no man's land, accepted that the ether didn't exist. It very much reminds me of the croissant effect. A professor of dermatology told me about this. He used to go and buy a month's supply of croissants at Marks and Spencer's, and when he went there, the shelves were full, you see. And then he'd get a trolley, and he'd start putting the croissants in. And people were watching this, and they thought, bloody hell, they must be a bargain. And suddenly the shelves were empty, and having to fight for to get the croissants, whereas previously they weren't bothered. And people want to be on board of something when it's happening, and it was a simple thing to go the wrong way and then get further and further down the wrong track. When I asked this question of what the heck's going on in this vacuum, I got the answer which made me laugh. Have you heard of Jasper Carrot? You won't have heard of him, would you? Well, he's a guy that makes me laugh. And he asked, one of his jokes was, why does it take 6 women with PMT to change a light bulb? It just does, that's why. Well, when I was asking my teachers why we were expected to believe that these things could happen with nothing mediating them, which is what we were expected to believe at 15 and 16, they were told, well, that's what science says, and there's no evidence for the ether, so you just have to accept it. And things like gravity were explained to me by this sort of thing, that gravitons were leaving here, causing an impulse that way, and going all the way around there and hitting the Earth, so that the force of attraction was produced in that sort of way. They hadn't got a better explanation than that, and it didn't seem very plausible to me. It seemed to me that the ether theory, with this being a space full of substance which we hadn't actually detected, but which we believed in on a self-evident basis, was much more plausible. And no matter how I protested, they said, that's what you believe, and you get on with it. And that will have happened to every one of you. I'm sure when you were faced with that at the age of 15, you would have rebelled against that situation. If you didn't, you were a bloody clever fella, because I don't know how you could have, at that time, understood concepts like that. Now, I'm going to leave it there and start by now telling you what I think the ether was. And this goes back 25 years when I started to try and answer these questions for myself, because nobody else was giving the answer. The most obvious contender for what the ether was energy itself. I looked for other possibilities, but energy seemed to be the leading contender. But the trouble was with energy, there were so many different variations of what people thought or meant by energy. Potential energy, chemical energy, heat energy, and so on. Now, unfortunately, these things are not all interchangeable. The scientist's use of the word energy is the ability to do work or the capacity to do work, and that doesn't fit the bill. Energy has to be thought of as a substance. And nuclear physics allows us to think that way because energy and matter are, as it were, interchangeable. So the energy thought of in nuclear physics terms as the energy that's released in atomic explosions, etc., is the type of energy that we're talking about here. So the first concept is, there's about 10 concepts that follow on from this. The first concept is that energy is the ether. The ether is made of energy. The second most important concept is that the ether, or the energy, has a property of self-attraction. That's its most important property. Now, the concepts that follow on from that are that the self-attraction varies in direct relationship to the density of the ether. The ether is not a uniform density. It varies in certain situations, which we'll come to later on. But one of the properties is self-attraction, and the self-attraction is directly proportional to the ether density. So that's concept number 3. And unlike energy in normal behavior when it's in a machine where it goes from high levels to low levels, in the ether it goes from high to high and away from low. This will be, I think, as we try to get the concept going, something which will be self-evident. So in a way, well, in fact, it obeys the inverse square law. Concept 4 is that all mass is a manifestation. I have to use the word manifestation because you can't say mass equals energy. All mass is a manifestation of ether density. Okay. Now, that means that mass and energy are interchangeable, and that you can make mass from energy, and that matter, which is a stabilized form of mass, is made from matter is a stabilized form of mass. So that is a concept number 4. But related to that is concept 7, which I've jumped into because that is that mass is the average energy density times volume. That's easy to explain. If you imagine, it's not as bad as it sounds. It gets easier as you go along. If you've got a cube of energy in there, etheric energy, that's the ether, you've got a cube of it there. If it's high density, then the total mass is the density times the volume, right? So if you've got a big volume, you've got more mass. If you've got a high density, you've got more mass. So that's a self-evident, again, concept that flows from that. Now, we've got to start asking some fundamental questions at this stage. What is a field? Now, a field is a maintained variation in what we call ground state energy. Now, I'm going to substitute the word ether for ground state energy. Can I, have we got something I can wipe this thing with? I'll use the flip chart. I'll just take these things over here so as I keep coming. If we imagine the ether, we draw this is a graph, and this is density up here, and this is distance. Can you? Grimace. That's actually red. All right. We'd like to come a bit closer. Or is that? I'll show you, see how you go on. What we're saying here is that if you've got a uniform level there of energy over a long distance, millions of miles maybe, then you won't get a field. But if the energy density is variable, then a field exists. So it's a variation in energy density that determines whether a field, and so that's concept number 5. And concept number 6 is the effect of a field is determined by the nature of the object experiencing it. So we can look at something as having an electric charge, as a proton or an electron. That in that field will behave in one sort of way, but something which just has properties of mass will behave in another. We have to incorporate all of these concepts into a single idea. So that is a field. That's not a field, or if it's a field with a zero field, that's a field which will behave. And in this situation, you see, as the density is increasing, then the attraction that the high density has will be greater than something here. So it will be attracted towards the high density end. I'm realizing that this is getting a bit tough for some of you, but it'll hopefully come a bit clearer later on. Now, how is the mass formed out of this ether? Well, if we take a lump, you've got to conceptualize this. If you can imagine a huge cube of the ether, we just isolate this. So we've got now all over the universe the ether. We're back to the ether again. And the ether we've postulated is energy. Now if we go right back to the very, very beginning of time, when this ether was just spread throughout the universe evenly, there was nothing there, just the ether. If at that point in time there was no disturbance in the ether, then all forces would be equal in all directions, wouldn't it? Okay? Because one particle of ether here and here, well, they weren't particles, but a little bit of ether here, would find itself being equally attracted in all directions. Yes? If we disturb the ether with a hand of God or whatever, and we start putting variations in the density of it, so let's put some vibrations in this ether, then here we've got high density ether, and there we've got low density ether. So things would move, using these concepts, towards the area of high density. That then would create areas of...
Could I interrupt you to ask, please, for the audience, on the basis of what experimental data do you know that it moves from high to high and not high to low? From high density to high density, instead of high density to low density.
Right, well, the
basis of what experimental evidence?
Well, this is not based on experimental evidence, it's based on observable phenomena.
On the basis of what observed phenomenon?
Well,
you know it goes from high density.
Well, that will come out, but I'll jump to that if you like, and that is if you take...
What's very interesting is that Wilhelm Reich said this about the orgone.
Exactly. Mm.
Well, are you talking about the orgone here?
I don't know.
Oh, that's very interesting.
I'm interested in the work of Wilhelm Reich because that's quite true, his orgone energy. The only thing is, you see, his was produced by an accumulator which was made up of vegetable metal material, and it seemed to come out out of a tube. It doesn't quite fit into this concept at this time, but you're quite right that the principles behind it are the same. But to answer the question, since you've asked it, if you take two masses together, we've said these are high density, and they attract, don't they, the gravitational forces towards each other. And so what we've shown there is that the high density attracts high density, so things will move to a point of high density. That comes out from observation. It's not experimental. We're just fitting in our own observations into the picture here. So we've got an isolated cube there, and if we disturb this energy so that we now have parts of this which are high energy areas and other parts which are rarefied as a consequence of that, then we start creating an immediate imbalance where some parts will cause an increased self-attraction and away from the reduced thing. So in fact you will get an implosion due to self-attraction, and it will implode to the point where energy into the picture here. So we've got an isolated cube there, and if we disturb this energy so that we now have parts of this which are high energy areas and other parts which are rarefied as a consequence of that, then we start creating an immediate imbalance where some parts will cause an increased self-attraction and away from the reduced thing. So in fact you will get an implosion due to self-attraction, and it will implode to the point where energy comes together to form...
Excuse me, could you define for the audience the word implosion? Could you tell them what implosion is?
Implosion as the opposite to explosion, where things dissipate away from a central point. In this case, implosion means everything concentrates towards a central point. Do you all understand the use of the word implosion? Yeah. So implosion, in effect, takes place, and I'm postulating, and these are only postulates, I'd just like you to bear with me until we've gone a bit further, that these will then form a definite size particle from the ether that was there in the first place, and that particle is done at the expense of the ether material. So in a way you've gathered all the stuff from a big hole, put it together and left the hole behind it, so that the particle is now very, very strong, self-attractive, because that's the property of it. It is highly self-attractive, and therefore it's imploding, imploding, imploding. And that is a lump of matter which 25 years ago I regarded as the proton, and the hole left behind it, that little dot was the proton, and the hole left behind it was the electron, because this has now negative energy compared to the ground state energy. So if we take these two situations and take the cube away and de-isolate it, as it were, so that the ether is now joined up again, we're left with a particle that was made from all that energy collapsed in on itself, leaving behind a hole. Now this is on the micro scale. Obviously now, in the acceptance of black holes, and we've got to ask the question, a black hole in what? Again, a black hole could be the macro version of that concept, so that here these are huge things rather than the microscopic things which we went with. Now this, in a way, would have positive charge insofar as, put back in the ether, if we have in a field here, because it's of itself a very, very high density, it's a peak, a massive peak of energy in graphical terms, it will attract towards the ether field, which is what I call ether is ground state energy, GSE. That's what you referred to there. So this is ground state energy when, in primordial time, when before all the earth and moon and everything existed, this was the way the ether was, and then it was disturbed, and these were the first forms of matter to form, and these high density forms of matter could then coalesce so that they started to group together into stable forms, and this would have a negative field compared in this situation, because it's of low, it's subnormal energy, and it would be attracted in a way towards the opposite end. It would go towards low density energy. So in pure simplistic terms, we've provided this, using the same concept, the concept that we started with of ground state energy, provided some possible explanation for electromagnetic fields, as well as trying to find how substance or matter can be generated from the etheric background. Now, coming on to further concepts, any object in a field experiences a force. Now, sometimes the object is neutral in that, in the case of a proton and an electron, the forces roughly equate to each other, but our definition of mass is determined by the amount of effort required to accelerate it. That's how you measure mass. That's the definition of mass. And we'll use that bit of information later on to try and validate the things which I've said so far in an elementary mathematical way. Next concept is that the force on any object in a field is directly proportional to the energy gradient, and we've illustrated up there. So let's put some of this into mathematics at what did I do with that pen? What we've said is that a force, this is the mathematics, that's not very good, is it? Did I, a force varies. You all familiar with this term mathematically? A force varies as the dx, right? Now what we're saying here is that in this situation, a particle here in a field is going to be affected by the variation in the field. If it's a very deep variation, then the force is going to be greater. If it's a very small variation, then it's going to be smaller. So we're just saying that the force varies as the energy density over the distance. This is basically what we do. This is, we take a small segment of that and call that a little segment of energy called dE, and that little bit is a distance, which we call dx. Okay? And we derive that equation. All right so far? Right. Now, what we can then say is mathematically that F equals, and I'm going to use a constant now, dE dx. Now what that is, a constant allows us to remove that and put an equal sign. We don't know what this is, it's just a plain number. It's a number, that's all it is. But it allows us to go from there to there mathematically. That's right, isn't it? We've got a scientist who'll verify. Some of them are looking a bit skeptical. Right, well that's allowable mathematically to go from that statement to that statement. Now what we're going to do is to check on whether this fits in by bringing it down to its dimensions. If we take Newton, Isaac Newton, if you remember, said a force equals mass times acceleration. The way scientists analyze things is doing what we call a dimensional analysis. Now dimensional analysis is to make sure that what we've got on this side of the equation is the same as what we've got on that side of the equation.
Excuse me, Doctor, I want to cut in here. I want to tell you that if you want to allow time for questions, and I think there's going to be dozens, we only have about 8 minutes longer. So if you want to allow time for questions, you got to allow time.
I think we'll make it.
Okay.
Okay. We don't get too many interruptions.
It's not an interruption, I can assure you. It's a time constraint.
Newton said force equals mass times acceleration. Mass is one of the dimensions, length is the other, and time is the other. They're the three basic dimensions. So if we can say on this side of the equation, starting up here, just to remind you, F equals dE dx. We're forgetting about the constant because that doesn't come into it. So force equals mass times acceleration. So force equals mass times acceleration is feet per second squared, right? So that's distance over second squared, correct? That's the dimensional analysis of that side of the equation. And here we've got the E dx. Now E if you remember, equals mc squared. That's where the torque comes from. So let's substitute E here, equals mc squared. That is mass, which we're just putting back here, and c squared is distance squared over time squared. Right? And then we've got to put that bit in the equation again, which, hold on, something's gone wrong. Oh, that's right, that's squared on the top. Now, that actually balances out to that. It's not much of a validation, but it's the important first step. If that had gone wrong, then the whole thing would have had to be rejected at that point. These equations and these constants can now be worked out, and hopefully we'll come to that. But this is the crux of the whole thing. The contender for what you might call the universal equation is that dE dx. And that is based on going back to the ether theory, that ether is energy. As we deduce the whole thing then from that, going back to that concept, F equals a constant dE dx, and that is the simple mathematic validation for that comment. Right, now we're well into it now, and I can at that point sort of back off and let you get at me, but I can predict some of the questions. Why can't we detect the ether in the first place? Well, we can only detect ethers or anything else by transducing it. It's got to go through a change, and that means you've got to have something at much lower level and something at much higher level for the energy to go through a meter, which will allow its detection. It's difficult to measure because you can't get a sink. Well, you can. If you've got a black hole, you've got the perfect sink. So if you own a black hole, you've got a huge potential for energy conversion. They could appreciate rapidly those. If you could got one, hang on to it. The concept of gravity now is easy to visualize. If going back to the first question that schoolboys always balk at, we've now put something in there that will mediate the force. This is a huge mass, right? And that, in here we've got ether. The ether is being attracted towards this huge mass, isn't it? So there's a sort of an increasing density of ether close to these these masses, and there's a similar increase in density there. We've got a rarefaction as a result of that. These are the ether's being sucked or pulled away, and the ether then is trying to draw together. It wants to achieve equilibrium. So we've now been able to conceptualize what these forces consist of. This also would allow us to explain time and space warps, because the energy density is greater here, considerably greater close to the surface of a massive object, than it is in the rarefied outer space. And so that light traveling in there, they say that the speed of light is a constant, well, but they say, yeah, but it travels at different speeds through glass and water. So there's still a constant. So if it's going through a heavy density of ether here, it will appear to be warped, and we measure time and space warps in what happens to things as we measure them.
Doctor, don't you think it'd be fair to the audience now to let them have some questions? We have about 3 minutes now instead of 7. So do you think that'd be a good idea?
Yep.
There's a question right next to Dr. Betts.
If the ether attracts itself,
Yeah.
what stops the whole universe collapsing in on itself?
The collapse you'd have to go really back to the primordial times. If we take, I have to conceptualize, imagine the vastest thing you can think of, and this is disturbed. God comes along, puts the finger in, and he disturbs the whole thing. What will then happen is that you've got different points where what I showed with that little cube was happening. So multitude of a whole of these events throughout the whole area of the universe. That little cube, do you remember the little cube I was talking about, which you collapsed into form a proton and electron? If you have lots of these all over the place, then you will have these things coalescing in one area and expanding and causing rarefactions in another. So the universe won't collapse in on itself because what comes out of this is the very small disturbance there. Instead of the Big Bang, if we go back right to the beginning and assume that ground state energy or ether permeate everywhere, and then you put a disturbance in that, then you will start to get coalition of and forming of mass, but it will happen in multitude of different places.
When we were 15 years old, maybe most people thought that the Earth was just a dead planet floating in space. People now realize that in fact the Earth is a living entity with its own requirements, which we humans must learn to live in accommodation with. Am I right in thinking that your work really, so far as the space is concerned, is to show that in fact it is a pulsating rhythm of its own, which, so that it is far from dead, there really is something there which, if we can but appreciate its existence, live in harmony with the whole universe.
I understand the question, and it's probably a difficult one to answer. Let me just comment on the work of David Bohm. You've probably heard of him, who regards that any part of the universe is really a hologram of the whole of it. That was one of the things he said. The second thing he said also, and this fits in my view nicely, because the ether, where no matter how it's disturbed, it goes on to infinity. Any small disturbance goes on to infinity. But thought was part of a spectrum in David Bohm's thinking, that you've got heavy density matter at one end going right through the whole electromagnetic spectrum and coming out at the other at thought. Now that is not such an implausible thing, because I often do a thought experiment with people, and you are amazing energy or thought transducers. If I said to one of you, right, come out and entertain everybody else for 5 minutes, right, you come out and do it, what will happen? Or if I just threatened you that I was going to do that, you would start getting energy changes in your body, you'd start producing adrenaline, etc. Now, I've not changed my tone of my voice or anything else, but you have produced a physical reaction as a result of a thought that I had. Do you follow that? Now, how far that goes into the Earth having a mind, I use the word, how does the Earth know to go around the sun? These are philosophical questions or metaphysical ones. I don't know the answer to them, but maybe those few comments will...
Excuse me, ask a brief question. Have you read the work by John Davidson called The Creative Vacuum, in which he talks about vacuum as being full of energy, and things can be drawn out of the vacuum?
All I know is that there's some activity. I'm a GP, you see, and I'm going back to work, which I did 25 years ago. So I wrote the article 25 years ago, and I've just brought it out and dusted it down, because I know the energy, the ether theory, or vacuum, which is is now coming back in vogue, and an energy has been postulated by new thinkers as well. What I've not seen is that equation which flows from that, and so if that equation is valid, then it validates to some extent the ether theory and the reintroduction of it. And then if you go back and look at all these phenomena like black holes and lasers, we can, and these submolecular particles which seem to exist as small vortices for time, but they have properties of matter and charge, they can all be fitted in to the ether as an energy much better than a vacuum which is totally non-existent.
Yes, ma'am.
Last year, did you hear Dr. Julian? Were you here last year? Did you hear Dr. Julian Kenyon speaking on the subject?
No,
And the work that he's doing in the star hours in the fields?
no.
Well, I think you should contact him.
Why?
I'd like to ask one question, if I may be allowed. This is not to recognize him as any greater or lesser authority than myself or Dr. Rainey, but I'd like to ask Professor Betts, Professor of Physics, what he thinks of that mathematics, or whether he could explain it better to me than, or what.
But to me, that makes sense. I mean, that's absolutely legal. And as I indicated in my statement before, the present view in modern physics really is that the vacuum is full of anything, if you like, energy. And that is a concept which is not at variance with what we know. And I think if you look at the propagation of light and the whole discussion of the dualism, is light a wave or a particle, you know, and we see that it behaves like both at the same time. A particle which can go through two different doors at the same time, you know. I mean, what we see to happen in physics is much more surprising compared to parapsychology, you know. And there are really fantastic phenomena which we cannot fully describe. But this concept of this ether, if you like to call it this way, I think it makes a lot of sense. And I could imagine that one modifies modern theories along these lines. All these hidden particles in the ether transmit energy. So what many physicists think that when electromagnetic radiation, for example light, passes through the vacuum, it's really a communication in the ether where particles are created, destroyed. So there is a certain transmission, like you have the transmission of sound in the air. You know, one particle hits the other. So in the ether, particles are created and destroyed. And by this concept, it's much easier to understand why a wave can behave like a particle under certain
Yeah, because the wave,
circumstances.
and that's why you can't have half a wave. You know, you just can't have half a wave, and hence you've got the quantum theory covered by that.
No, I would think as long as you don't violate things which are definitely certain, it's completely legal to think along these lines. But I have one short question. I have not yet had the time to think about it right now. Can you accommodate antimatter in this concept?
Well, I couldn't until recently. If you look on the thing there, you know, that was written in 1970, and I said that one of the difficulties I was having was accommodating antimatter. But now I can accommodate it, and at least ways I think I can. And that's because this, you know, dark matter, the weight of the universe is, and not, when you weigh all of the universe, it seems to be only half what it ought to be. That's what scientists have said. You know, there's missing mass somewhere, and if the ether really could be that missing mass. Now, what that means is that we do know the weight of the universe. Scientists can calculate that. And if we divide that by the dimensions of the universe, we've then got a figure for the ether energy density. Now, the ether energy density is thought to be much greater than, if it was only a very thin thing, then what? I'm sorry about this, but if we got a there we are. If it was only a very thin thing, then you could have a great concentration, but you could only have a small rarefaction, right? But if it's up here, you can have a great concentration and a great rarefaction. So it would allow for huge depths of negative energy in the web below the thing, and that would then be the nearest you could get to antimatter, huge holes in the energy density.
Have you got anything to say to that, Hans Dieter? If that's okay, we're all okay, and we want to thank Dr. Rainey very much.
I've only got one thing to say, and if I can find it here. It was in response to that gentleman up there, and that this idea of thought being part of a total spectrum, and we're here because we don't like, as much as anything, the way the world's going at the moment, and our thoughts could influence it.